Hi, welcome back. Here we have October 2019, question number 10. Figure 6 shows a sketch of the part of the curve with the equation y is equals to f of x, where f of x is equal to 2x plus 5 into x minus 3, the whole square. Now, let's first find out the x-intercepts here. We have two x-intercept here. One is on the negative side of the x-axis and the other one is on the positive side of the x-axis. I can see that the curve is only touching the x-axis here. That means at this point, there will be a repeated root. Let's find out what the x-intercepts are. So for finding out x-intercept, we'll put y as 0. So 0 is equals to 2x plus 5 into x minus 3, the whole square means it is x minus 3 into x minus 3. Equate them separately, we will get x as minus 5 by 2 and x as 3, x is equals to 3. We have the repeated root here at x is equals to 3. So we know if we have a repeated root at that point, the curve will only touch the x-axis. So this is the point where 3 is, and this is minus 5 over 2. The question here, deduce the values of x for which f of x is less than or equal to 0. Now this f of x less than or equal to 0 means the portion of the curve, the portion of this curve below the x-axis or on the x-axis. Or on the x-axis, the reason is that it has that equal to sign. So f of x less than or equal to 0 means the portion of the curve which is below the x-axis or on the x-axis. I can see the portion of the curve below the x-axis is from minus 5 by 2 towards the left of it. Minus 5 by 2 towards left of it means your x values should be less than or equal to minus 5 by 2 because it can be 0 or it can be negative. Y values can be 0 or y values can be negative. That is happening when your x is minus 5 by 2 or less than minus 5 by 2. All your y values are negative. Similarly, we have one more. When x is equals to 3, the curve is touching the x-axis. So at that point, your y value is 0. So therefore, x is equals to 3 is also another point for the solution, another solution for that inequality. Now, the curve crosses the y-axis at the point P. So you can see y-axis at the point P, that's basically the y-intercept. First, expand f of x to the form ax cubed plus bx squared plus cx plus d. We have f of x 2x plus 5 into x minus 3, the whole square. So 2x plus 5 into x minus 3, the whole square, that is x square minus 6x plus 9. Let's expand the bracket. 2x into x square will give you 2x cube. 2x into minus 6x will give you minus 12x square. 2x into 9 will give us 18x. 5 into x square, 5x square. 5 into minus 6x, that is minus 30x. And 5 into 9, that is 45. Collecting the like terms, so 2x cube minus 12x square minus 12x square plus 5x square, that is minus 7x square plus 18x minus 30x, that is minus 12x plus 45, where a, b, c and d are the integers to be found. So here when we compare, we'll get a as 2, b as minus 7, c is minus 12 and d is equals to 45. Hence or otherwise, find the coordinates of P. We know that P is the y-intercept. So how do we find out the y-intercept? Just substituting in this equation. In this equation, substitute for x0 here. So when you substitute for x0, you will end up with 45. 2x cube will be 0, 7x square will be 0, and 12x will be 0. And you will be left with 45. So your point over here, coordinates will be 0, 45. Since it is a point on the y-axis, its x component or x coordinate is going to be 0. Now, we need to find out the gradient of the curve at P. So, how do we find out the gradient of the curve at P? Gradient is by finding the derivative of the function. So, the function is 2x cube minus 7x square minus 12x plus 45. So, if I find out the derivative, 2x cube will be 6x square, 7x square will be 14x minus 12. So, it's given that at P, we already know the coordinates, that is P is 0, 45. Gradient will always be a number, it cannot be an expression. So what we have to do is just take the x coordinate and substitute it here. So x is 0, so 6 into 0 is 0, minus 14 into 0 is 0, minus 12. So this is basically minus 12. So you'll be getting the gradient as minus 12, a negative gradient. Now the curve with the equation y is equals to f of x is translated to 2 units in the positive x direction to a curve with the equation y is equals to g of x. Find g of x giving your answer in a simplified factorized form. So here we have to find out g of x. What they have mentioned here about g of x is that 2 units has been translated towards the right. So let's see here, minus 5 by 2. If we are moving 2 units towards the right, minus 5 by 2 is basically minus 2.5. This will be minus 1 over 2 or minus 0.5. And then 3, when you shift it 2 towards the right, so 3 will become 5. So my new graph will be something like this here. I can see that g of x, it is cutting at minus 1, it's cutting the x-axis at minus 1 by 2, and it is touching the x-axis at 5. So at 5, it should be a repeated root. Minus 1 by 2. Minus 1 by 2 is basically, that is 2x plus 1. 2x plus 1, when you equate it to 0, you will get minus 1 by 2. And 5, we know that is x minus 5. X minus 5, when you equate it to 0, you will get 5. And 2x plus 1, when you equate it to 0, you will get minus 1 by 2. Since we have a repeated root at 5, so you square it. This is the function, factorized form of g of x. Finally, the last part of this question is to find out the y-intercept of the curve, y-intercept of g of x. Y-intercept of g of x is what they are asking us to find out. Now, how do you find out y-intercept? Just put x as 0. So 0 plus 1 is 1, and 0 minus 5, that is minus 5. Minus 5, the whole square is 25. So 1 into 25, 25. 25 will be your y-intercept, or you can say that this point over here, this is 0, 25. If you are representing it as a coordinate, or else you can simply say that your y-intercept is 25. So I hope you have understood this. Thank you for watching.